ECE27 Performance Task Number 4 by Raymond Lorca BS ECE 3A. Difference Pulse Code Modulation. Differential pulse code modulation is a method of converting analog to digital signal. This method samples an analog signal, quantizes the difference between the sampled and anticipated values, and then encodes the signal into a digital value. This is a signal encoder that employs the baseline of pulse code modulation or PCM but adds functionality based on signal sample prediction. An analog or digital signal can be used as an input. Differential pulse code modulation is a method of transforming an analog signal to digital signal in which the difference between the actual sample value and anticipated value, predicted value in it, is dependent on previous sample or samples, is quantized and encoded, resulting in a digital value. Unlike PCM, which use code words to indicate sample values, the PCM code words express changes between samples. The figure shown a continuing time signal x of t denoted by a dot line. This signal is sampled by flat top sampling at intervals Ts, 2Ts, 3Ts, so on. The signal frequency is selected to be higher than Nyquist rate. These samples are encoded by using 3 bits, 7 levels PCM. The samples are quantized to the nearest digital level as shown by small circles in the above figure. The encoded binary value of each sample is written in the top of the samples. Just observe the above figure at the samples taken at 4Ts, 5Ts, and 6Ts are encoded to the same value of 110. This information can be carried only by one sample value, but the 3 samples are carrying the same information means redundancy. Now, let's consider the samples at 9Ts and 10Ts. The difference between these samples only due to the last bits and first 2 bits are redundant since they do not change. So, in order to make the process this redundant information and to have a better output, it is intelligent decision to take a predicted sample value, assume that it's a previous output, and summarize them with the quantized value. Such a process is called differential PCM or DPCM technique. Principle of differential pulse code modulation. When redundancy is reduced, the total byte rate is lowered as is the number of bits necessary to transmit a single sample. Differential pulse code modulation is a sort of digital pulse modulation method. The DPCM is based on the prediction principle. The current sample's values is anticipated based on the prior samples. Although the prediction isn't perfect, it's quite near to the actual sample. Differential pulse code modulation transmitter. Here shown the DPCM transmitter. The transmitter consists of a comparator, quantizer, prediction filter, and encoder. The sample signal is denoted by X of NTS and the prediction signal is indicated by X raised to NTS. The comparator finds out the difference between the actual sample value X NTS and the predicted value X raised to NTS. This is called signal error and it is denoted as E of NTS. E of NTS is equal to X of NTS minus X raised to NTS and so on. Here, the predicted value of X NTS is produced by Using a prediction filter signal processing filter, the quantizer output signal EQ-NTS, and the previous prediction is added and given as input to the prediction filter. This signal is denoted by XQ-NTS. This makes the prediction closer to the actual sample signal. The quantizer error signal EQ of NTS is very small and can be encoded by using a small number of bits. Thus, the number of bits per sample is reduced in DPCM. The quantizer output would be written as EQ of NTS is equal to E of NTS plus Q of NTS, and so on. Here, Q of NTS is quantization error. From the above block diagram, the prediction filter input X and XQ of NTS is obtained by sum of X raised to NTS and quantizer output EQ of NTS. XQ of NTS is equal to X raised to NTS plus EQ of NTS, and so on. By substituting the value of EQ of NTS from the equation 2 and in equation 3, we get XQ of NTS is equal to X raised to NTS plus E of NTS plus Q of NTS. Equation 1 is written as E of NTS plus X raised to NTS is equal to X of NTS, and so on. From the above equation 4 and 5, we get XQ of NTS plus X of NTS plus X of NTS. Therefore, the quantized version of signal XQ of NTS is the sum of original sample value and quantized error Q of NTS. The quantized error can be positive or negative, so the output of the prediction filter does not depend on its characteristic. Differential postcode modulation receiver. The DPCM receiver shown below is made up of a decoder and a prediction filter that work together to recreate a received digital signal. The encoder receiver input, the input and encoded transmitter output will be identical in the absence of noise. As previously stated, predictor calculates a value based on a past output. The decoder input is processed and decoder output is combined with the predictor's output to get a superior result. That is, the decoder will recreate the original signal quantized from first as a result of quantization error Q of NTS, which is permanently introduced in the reconstructed signal. The signal at the receiver varies from the real signal. This is the table of comparison of PCM and DPCM.